In this tutorial, we are going to see how to define a queuing network in JMT. We have created a model with a source, a sink, and 3 queues. Each queue is a FCFS queue with exponentially distributed service times having a rate of 1. We have defined one class of jobs which has an inter-arrival time distribution that is exponential with the rate 0.5. So one job will arrive on average every 2 units of time. We now connect this source and the queues, making sure that all the outputs of Q2 and Q3 go to the sink, so that the job can leave the model. Compared to a regular model of a single queue, here you have the issue that you need to specify how jobs are routed out of Q1 to Q2 and Q3. To do this, we click on Q1, go to the routing section and specify the routing policy that we want. In the case of the random policy, the 2 destinations will be chosen with the same probability, so purely at random. With round robin, they will be chosen in turn, and with probabilities, you can specify the probability of sending jobs to Q2 and Q3. For example, 0.4 probability to Q2 and 0.6 probability to Q3. We now define the performance indices for this simulation. For example, we can look, as we have done before, to the response time of class 1 at Q1, but we have now also the option to look at the same quantity at the other queues. In addition, when we consider a complex system like this, we should take into consideration the system performance indexes. For example, if we look at the system response time, this is associated to class 1, and we calculate the average response time that the job takes to go from the source to the sink. In other words, to traverse the entire system. So we give the OK and we start our simulation. This model is quite simple, and as you see from the simulation, you can immediately graphically tell which of the queues is going slower, which is Q1. You can see that the queue length of jobs accumulated at Q1 is longer than for Q2 and Q3, and this is because of the probabilistic routing, which reduces the intensity of the arrivals at the 2 queues compared to the arrivals at Q1. As you can see, you can look at the results of the simulation through 2 panels for the system response time and for the response time at the individual queues. You can distinguish to which queue a metric pertains under the station name you see here.